This is part 2 of the method for Unit 22, Assignment 1, Experiment 4. So, part 2. And what we've started with is we've got our so from part 1 we've got water with caffeine dissolved. So that's our starting point. And the main bit of kit that we're using here is a separating funnel. In your method it says add 100 cm cubed of chloroform and change that to 30. There's too much chloroform otherwise. Right, so the separating funnel, that looks like this. So it's kind of funnel shaped, as the name suggests. And it's got a lid. And it's got a tap so we can control the flow. And so what we've got to put in this, we have got chloroform, and we've got our water with caffeine dissolved, and we're going to put in our water and we're going to put in 30 cm cubed of chloroform, and that's step 1. It says shake thoroughly. So when that's closed off, you shake this and then it forms kind of we'll have the kind of top level of the surface of liquid air, and then it'll have a separating layer. And these layers will be so we're gonna shake this, and actually what happens is the chloroform settles at the bottom and the water settles on top. That's because the chloroform is more dense than the water. So step 2 is allowing the chloroform to settle at the bottom of the separating funnel. We're going to then open the tap and drain the chloroform into a beaker. And hopefully now this will be our chloroform plus our caffeine dissolved in there now. So hopefully that's what will happen there. And we're just going to dispose of our aqueous top layer. So we dispose of the water. That's going to just get binned. We don't need that anymore. And then we're going to filter this again. We're going to filter this again. I'm going to put that in black for consistency. So step number 3 is we're setting up a filter much as before. We've got our normal arrangement there. We're going to put our chloroform and caffeine mixture into there, but this time we've got a different filter that we're using. This is a reverse phase filter, and that's going to keep anything watery or polar, and so we just get here our kind of more pure version of our caffeine solution in chloroform So this will still be chloroform plus caffeine, but hopefully less water. So we just need to do the same we need to salt out M1 and M2. So M1 explaining the steps, M2 pointing out problems or things that would happen if we didn't do them. So we've got step 1. Why did we add chloroform? So we were adding chloroform. Well, caffeine is more soluble at room temperature in chloroform, and so will transfer to the chloroform when you shake it. So it's a way of getting it dissolved at room temperature. So caffeine is more soluble at room temperature in chloroform than water, and so will transfer to it. We were shaking it. Why did we shake it? To make sure all the caffeine comes into contact with the chloroform. So shake to ensure that all the caffeine comes into contact with the chloroform. What else do we have? We had the separating funnel. What's that for? So it's got a tap on the bottom. Which allows the more dense liquid to be removed, leaving the less dense liquid. So this allows liquids of different density to be separated. And we'll also mention the chloroform has a higher density, so will be on the bottom. If we didn't do that, some caffeine might remain in the water. So some caffeine would remain in the water, or you wouldn't be able to remove it. So we'll leave that there for the moment. 2. Why did we open this tap? So we can just remove the chloroform. So tap allows just the chloroform to be removed. Or we would be contaminated with water. And step number 3, this is our reverse phase filter. So this is our what this does, it traps any kind of watery molecules like water or anything, dissolved in water. So traps polar liquids like water. The paper is actually coated in silicon, which helps it kind of repel the water. So paper coated in silicon, which repels water. And for M2, what would be the problem if that didn't happen? Well, water and solids, if we didn't filter this, water and solids would get through and contaminate the product. And that's part 2.